I'm Charlie Stripp, the current president of the Maths Association, and during my time as president this year, I want to talk about. Well, there are three themes that I want to address. One is about negative attitudes to maths and maths education. One is about the chronic teacher shortage we have in secondary and post-16 maths, and the other is thinking around how, generally speaking, in our maths teaching, we don't make good use of technology, and we really should be doing better with that. But today, I'm talking to David Thomas, and David is the chief executive of Axiom Maths. And the particular reason I want to talk to David is because it's around the attitudes to maths and maths education. And I'm especially keen to talk to him in this format because I saw him give a talk where um, we all well we know that there's a drop off in maths performance, maths interest sometimes between key stage 2 and key stage 3. We know that that seems to affect children from a less advantaged background more than others. And I've often wondered about that, but I've never really had a proper sort of plausible explanation for why it happens. And I think that David, through his Axiom Maths work, has really looked at this in detail, done some research around it, and I was very taken by what he had to say. So, David, perhaps you could start by talking about that work.
Yeah, of course. So we started picking up off the back of some work that Andy Noyes and team did at University of Nottingham about trajectories through children's mathematical journeys, and they found that between the ages of 11 and 16, there's a 50% attrition rate for disadvantaged children in the there's top achievements of mathematics. So half of children who score very highly on their Key Stage 2 SATs in mathematics who are from more disadvantaged backgrounds don't go on to get a grade 7 or higher at GCSE. And we were interested in why that was, what was going on. And when you look at the international evidence about maths attainment in England, we see that we're doing really well at primary. We see that we're doing pretty well in PISA at the end of secondary, but we see that year nine TIMS is pretty flat. So we said, look, it looks like something's going on between the ages of 11 and 14 and wanted to zoom in a little bit on that. So we did some work with a research agency surveying 10-year-olds, 11-year-olds, 12-year-olds, 13-year-olds about their experiences of maths in school and their attitude to maths. And what that told us is a really sharp drop off between the end of year six and the end of year seven in terms of what children think about mathematics and how they experience it. So, children, as they moved from year six into year seven, children who did well in their Key Stage 2 SATs, they find maths easier in year seven. They find it more boring in year seven. They find it less fun in year seven. And that's not because they think that secondary schools are inherently boring. They actually think their secondary teachers are trying harder than their primary teachers to make maths interesting. So they think their teachers are working harder, but the results not coming through. So these kids are saying, look, I'm finding maths boring. I'm finding it too easy. It's not very fun. And and at the same time, the children who did well in their Key Stage 2 SATs in a new environment are telling us that they're feeling really self-conscious about appearing to be good at maths, and they're really worried about the social dynamics of secondary school. And their parents, who we also surveyed, are feeling really worried about the social dynamics of moving into secondary school. There's a huge shift that happens between year six and year seven when you ask parents whether they think that their child being good at maths is going to have a positive or negative impact on their child's social group. When they're in year seven and eight, parents are saying, gosh, I'm really worried that my child being seen to be good at maths is going to be negative for them socially. So children are having a classroom experience where they are finding maths a bit boring, a bit too easy, not very fun, quite repetitive of what they did in primary school. And at the same time, they're navigating a new social dynamic where they want to fit in, they want to be seen to be cool, and they get, at least from when we asked them, they get really self-conscious about being seen to be good at maths and what that will do to them. And that's being reinforced by the messages they're getting at home as well.
Yeah. So it's almost sometimes I suppose you might think of peer pressure as being something that encourages that you'd be worried about not doing well enough. And what's happening here is that the peer pressure is making people worry that they're doing too well, and that kind of affects in their social group. That's an issue. I mean, I wonder whether, I mean, if you're I mean, if you're from a much more middle class background in that environment, how is your experience different?
So we looked at children's friendship groups as they move from primary into secondary school, and so we split children for the purposes of analysis by socioeconomic background and said, disadvantaged children, so in the bottom 30% on the IDACE, which is an index of
Yeah,
deprivation, and then the top 70%. And we asked children to describe their friends. So we said you gave them a kind of big screen full of descriptors that one might use to describe your friends. So like behaves in class, messes around in class, that kind of
yeah,
thing. Just click on all the things that describe your friends. And off the back of that, we sorted children into those who have kind of positive friendship groups,
yeah,
positive about school friendship groups, negative about school friendship groups, and just mixed. And when you're in year six, about a quarter of children have friendship groups that are negative about school. Uh, and your socioeconomic background has no impact. So it's a quarter of children. It's a quarter of children from disadvantaged backgrounds. It's a quarter of children from advantaged backgrounds. There's no difference. When you move into year seven, there's a huge divergence that happens. So it stays at a quarter for children from
yeah,
advantaged backgrounds, and it shoots up to about 40% for children from disadvantaged backgrounds. So there's a kind of resorting of social groups that happens when children move from primary into secondary school that leads to more disadvantaged children, and particularly more high attaining disadvantaged children. Perhaps those who are really socially aware, they're a bit more developed for their age, they've kind of spotted how things work, are feeling a pressure and acting on that pressure to move into social groups that are more negative about school. And that has a big follow through impact on their behavior, their attitudes, all of these things, because of course, we're all to a certain extent, right, the product of the people that we choose to spend time with.
yeah. That was the thing that I hadn't, I was really shocked by that when I heard you say that, and thought actually I can see how that really does make sense. It seems a very sort of plausible explanation for what happens. And I suppose the next question is, if you understand or you think you understand what's happening, how can we overcome it? What can we do? And I know that that's partly what Axiom is about, isn't it?
Yeah, obviously, look, we've got a bit of an answer to that, but we think that we only have a piece of the puzzle. I mean, at a school level, so much of this is just around the culture that you set. Now, one of the interesting things that we found in doing this research is the children are really aware of this kind of peer pressure, but it doesn't actually exist. So when you look at children's attitudes towards people who are good at maths,
Yes.
and you say, what do you think about people who are good at maths? Do you have negative, are they uncool? Are they geeky? Whatever. Um, there is no change when you move from year six into year seven amongst children who are low and mid attainers at mathematics.
Yeah.
The change in attitudes is entirely driven by high attainers. Right. So
Okay.
high attainers start saying that people who are good at maths must be geeky or uncool or whatever. They're the people who are driving the shift. There isn't a shift in the lower middle attainers. So the shift is entirely driven by the self-consciousness and concerns of
Yeah.
the high attaining children who are worried that there is an attitude that is going to be negative towards them, and they're getting that reinforced at home. So
Yeah.
I think that should give us like a little bit of confidence in our schools trying to shift this. That
Yeah.
the thing that we're worried about is a bit of an emperor's new clothes situation.
Oh,
Like it's
right.
not
Okay. Yeah. Yeah.
really there. And so I think that makes it easier than if it was real, right? To set that
Yeah.
culture where we're saying, look, everyone should be proud of what they're good at, and
Yes.
everyone should be able to thrive, and you shouldn't have to change who you are and hide your talents in order to fit in.
Yeah.
And indeed, a talent in mathematics is hugely valuable. That opens up all sorts of doors to you. I mean, if you're picking your friendship group, go on, pick the friend who's likely to be a millionaire when they grow up, and they're a mathematician.
Yeah. Yeah. No, that is fascinating. And I think, yeah, if there are, I mean, yeah, the idea that actually the fear that they have about their peers' attitudes to them is unfounded, but that fear is still very powerful. And so if we can find ways to address that, and you're right, if they were, I suppose they were right about that fear, it would be much harder to address. But what we're saying is that because it's something that's more their own fear about what's happening rather than the real fear, perhaps that's something that we can address by how we interact with those children and the kind of encouragement we give them and all of those things. So yeah, that's yeah. Thanks, Dave. That really, I've thought, and I'm sure many people in maths education have thought a lot about this, and what your research seems to be something that I was really, I was really taken by that. And I think it's something that it's great to be able to share that, and for us as a maths education community to think about how we can address it. Now, the other reason that I was very impressed by the time when I saw you speak is that you had a room full of people who were, some of them were maths people, and some of them were more kind of senior leader type people who weren't necessarily especially mathsy. And you started your talk by giving us all a maths problem, which I thought was quite brisky actually. Um, and so and I'll just explain what the maths problem was. So the maths problem was that you've got the digits 1 to 9 inclusive, and you make three-digit numbers from those digits, and the sum of those three-digit numbers, you want that sum to be 999. And the question was, can people in the room, work out the answer to that? What are the three numbers? And the problem's got an added twist that the mathematician in the room picked up on quite quickly. There's probably more than one way of doing this. And my experience of it was that I was sat between two people who weren't mathematicians, and so immediately I felt the peer pressure of them saying, "You're the mathematician. You need to help us with this." And I thought, "Oh God, that." And so I felt that I was experiencing a bit, perhaps, of what people that are good at maths experience at school sometimes, and I'd forgotten about that. Um, but the other thing is that my response to this was, the way to start any problem like this is just find three numbers that fulfill the criterion of using all of those 9 digits and just see what happens, and then start thinking about it. And what happened with the problem is it really captured the attention, the imagination of the two non-mathematicians. And so, having said to them, just have a go, they then got completely absorbed in it. And then we started to think about, in fact, what was interesting is that they came up with two different answers quite quickly. So then it was okay. So can we work out how many different answers there might be? And that led to a different type of thinking, which again is showing the power of maths that you don't have to hunt for them all. You can reason out how many there are. And so absolutely brilliant problem. I mean, David, you're probably going to tell me that that you're probably going to tell me that's exactly why you set that problem. I mean, am I right about that?
Yeah, I can't take any credit for the problem. That was one of the team who came up with it. But yeah, and that's a problem that devised deliberately uh, for a mixed audience to be able to give you very quickly an insight into what mathematical problem solving feels like.
Yeah.
Because you're right, uh, you maybe are daunted to start with. You realize that you've got to just put something down on paper, so you've got a starting point, and then you can start to iterate. Um, and then you get a solution. You feel really proud of yourself, and then someone comes along and, in a slightly maths teacher, irritating maths teacher's voice, says, "Aha! But how many ways are there of doing that?" And then you get a moment of and then you go, "Oh, that's very interesting," and you start to reason through what are the conditions that need to be made, and then you get to a point where you start to realize, well, I need certain combinations of numbers in one column and certain combinations of numbers in another column, and I won't go into more because people might want to do the problem, and I won't ruin it for them. But yeah, you can get into that and get into the reasoning and the logic of that without having to be what many people would think of as kind of good at maths, right? You don't need an A
Yeah.
level in further maths to be able to get into that. You just need to be able to do sums up to 20,
Yeah.
really.
I mean, the thing I was going to ask you about also was, have you experienced children doing that problem, and what ages of children do it? Have done it, and what's their reaction to it?
Oh, that's interesting. Um, so I think we've used that with, so that's not a problem from our math circle curriculum,
Yeah.
deliberately, because we're picking some people in a scene. And that's, I think, the sort of problem that we would actually be writing for kind of year 5 and 6.
Yeah.
Um, and have seen some children do that. And again, this is pretty much the same. And that's one of the joys about some of these
Mm.
this maths, right? Is that you can get into the logic and the reasoning without needing a certain kind of level of mathematics. And actually, an interested 10 or 11-year-old doing that problem can have a crack at that exactly the same way
Yeah,
as, I don't know, whichever sort of professor of not mathematics that you were sitting by at that event.
yeah, yeah. No, it's really interesting. I know that something that I'm very keen on is I like the yeah. I mean, the Maths Association has a primary maths challenge, and there are the UKMT maths challenges. And I always, well, when I was teaching myself, I always tried to make use of those, and I always encourage teachers to use them. But the surprising number of maths teachers actually don't even know about them. But what is people's reaction to them often is surely they're kind of inaccessible, and they're going to emphasize the kind of people who aren't good at maths are going to have that view reinforced, and people who are good at maths are, some of them might have their confidence shattered by the idea that being good at maths isn't what they thought it was, and all of those things. And I actually think that they're if it depends how you present them. If you just present them as let's have a go at this, it'll be a fun thing to do. And I think that's that one of my things about attitudes to maths is to think about that human beings are kind of we're problem solving machines, aren't we? But what you want is to try to get that instill that kind of love of thinking about problem solving amongst young people. There's there's a little poem that I like. There's a Danish guy called Piet Hein. I think he did some stuff with he's a bit of a polymath, an architect and a bit of maths, bit of literature, that kind of thing. But his poem's called Grooks, and I think the one I'm thinking of is a problem worthy of attack proves its worth by fighting back. So I think if you've got a kind of a bit like the fighting back by but how many ways are there of doing that? If you're a you've got a kind of I'm sure we can cultivate this disposition amongst young people that actually it's not that I'm threatened by a problem that I can't solve. I'm interested by a problem that I can't solve.
Hmm.
Yeah, perhaps I'm being too but perhaps I'm being too optimistic. But by my own experience of trying to teach suggests that sometimes you can succeed in getting people to think in that way.
Yeah, and we talk a lot to the children that we work with about getting stuck and then unstuck.
Mm.
And I think lots of children come at maths with the preconception that if you get stuck, it means you're bad.
Yes.
It means you're not good at maths. There's
Mm.
something wrong about getting stuck. Now, I don't want to glamorize getting stuck because that's not the
Yeah.
goal, right? That's why we
Yeah.
talk about getting stuck and then unstuck.
Yes.
Um, but getting stuck, I don't know about you, but the moment that I light up doing a maths problem is
Yeah.
the moment I get stuck. For
Yeah.
exactly the, your little ditty, right?
Yes.
Because that's the moment you go, oh, this is fun, right?
Yes.
This is going to be worth my time, right? If I'm never getting stuck during it, I'm doing something that I knew I could do. I'm not pushing
Yeah.
myself. The moment I get stuck is, oh, that's when I light up because getting out of that situation and then finding the solution is the exciting bit. Can I pick up on something you said
Yes. Of course.
about challenges as well? I think like I've done maths challenges. I love maths challenges. There's nothing wrong with maths challenges. I think they're great. I think there is something that is problematic about for so many children, the only kind of enrichment maths they ever see being a competition.
Right.
Um, and
Yeah. Something I should have said
mm,
then is that I don't necessarily
mm,
enter them for the competition. I
mm.
use the questions in appropriate places in my teaching.
Yeah, and that can be done, right? But I think it is true that lots of children's the only exposure they get
Yeah.
to kind of enrichment, extracurricular maths, something that's not their lesson, is a challenge, and that's very different to um to lots of other subjects or lots of other things, right? So in music, when I was a head teacher, I used to make every year seven sing in the choir for a term. And we
Yeah.
entered year seven as one choir of 180 children into the Norfolk Music Festival every year
Yeah.
because we thought that it was important for them to have that shared collective experience.
Yeah.
And we thought that every child should have the experience of performing some music on stage and every child could benefit from it,
Yeah.
even the ones who are not going to go on and become sort of professional singers or professional
Yes. Yeah.
musicians, right? And it's just interesting, like in maths so often you only get into enrichment or extracurricular if you can kind of if you're going to win the
Yeah. Yeah.
competition. And that joy of problem solving that people get from that 999 problem or
Yeah,
whatever else, that is available to everyone, and that should just be part of growing up and going to school in this country, that you get that light up experience. And
yeah,
I think we don't make it available for enough children.
yeah. I absolutely agree. I like that. Now, I also know that you've been doing some research and some polling and things with adults around attitudes to maths. So perhaps you could expand a bit on that.
Yeah. So we've kind of gone down the rabbit hole after looking at some of the stuff that I've talked about um children reflecting the attitudes that they think are there in society. So I want to say, well, actually, what are the attitudes in society? What do adults think about mathematics? And doing a bunch of work on this, asking adults, so it's about 2,000 grown-ups, what their views were on maths. And I was kind of expecting to get back from this that people are really down on maths, no one likes it, everyone's scared of it, all of these kind of things that as maths teachers we believe, right? Or at least talk ourselves into believing. And the data just doesn't support lots of that.
Okay.
And so when you just go and ask the population, do you enjoy maths? Right? Half of people say they agree or strongly agree that they enjoy doing mathematics. Right, so half of people, if you just ask them, do you enjoy doing maths? Half people say yes. A quarter of people say no. When you ask people whether you think maths is important for the country, important for the economy, a good thing for people to be doing, overwhelming support. When you ask people, do they use maths in their work and life? Huge majority are saying they do. When you ask them if they're confident in it and they think they're good at it, a huge majority. There are many more people think they're above average at mental maths and think they're below average at mental maths,
Yes.
which is in itself interesting. But that's not the case for everything, right? That's not the case across all things. You know, we asked about lots of other things to be able to just kind of check. Does people just all say they're above average at everything? No, people are really positive about their ability in mental maths,
Yeah.
and there is a segment of people, about 20 to 25% of the population, who who say they don't enjoy maths. There's only a quarter of people who say they don't enjoy doing maths. But there's a segment of about a quarter of people who don't enjoy doing maths, don't think they're very good at it. Um, but that's it. And these perceptions that mathematicians are antisocial, we ask people, what do you think about people who are good at maths? What do you think about mathematicians? They don't think they're antisocial. That's just that's just a myth. We even ask people, and the MA listeners will like this, how likely they would be to go on a date with someone who said they really like doing maths. Um, and 3 times as many people said they were very likely to do that as not likely to do that. So there are some causes for concern in there, that there's a majority of adults think that only some people can be good at maths. Like,
Yeah.
that's problematic. Um, but overall, we don't find evidence of an overwhelming society-wide dislike of maths. There's a small group of people who don't like it, but that's it.
Yeah, it's very interesting because it's something that it's certainly something I worry about. I mean, I've worried about it to the extent that I've made it one of the themes of my presidency to think about that problem. But on the other hand, I mean, there's some great news this year that the number of maths A-level students has passed 100,000 for the first time, and the number has gone up by I think over 11%. The cohort has increased by about a bit over 2%. So that means that there's a real shift towards maths. I you know whether the whether that's, I mean, obviously the people that choose to A-level maths are people who maybe are good at maths, whatever that means. But I'm so perhaps it's a little bit like what you were saying earlier about the students in Q stage three who they're kind of they kind of held back a little bit because they think that people will be against them if they're interested in maths. Maybe we should try to sort of do a bit of myth busting around attitudes to maths. Actually, we're not as a country against it, and let's just kind of relax about it and have everybody be much more just calm about the idea that maths is a really important thing and you should do it and can enjoy it.
Yeah, I think you're absolutely right. I mean, we just don't find evidence that people are really against maths. So how do you reconcile, what you've just said, how I've
Yes.
definitely felt as a maths teacher and
Yeah.
as someone, with maths teachers, right? We've all been that person who says in the pub to someone else that you're a maths teacher, and they go, "Oh, well, I've never been able to
Yeah.
do math." Right?
Yeah.
You become very self-conscious about it,
Yeah.
and maybe we over-index on those experiences and self-censor ourselves more than we really need to, and
Yeah.
much more than the evidence that we've got suggests that we would need to in order to just be in line with the rest of the non-mathematician population.
Yeah, that is really interesting. Well, I know that something I say, obviously, I do have lots of interactions with teachers, teaching in school, and something I'm always very bullish about is I never apologise for maths. Maths is, and I mean, you must have seen this as a teacher and a head teacher, David, that sometimes people are quite, I mean, I've heard, I hear say things like, everybody finds this hard. Don't worry too much about it. And I think that's not the right way to deal with it. It's much better to be, that this is, this isn't nearly as hard as you might think it is, and we can make sense of it, and it's yeah. So maybe because we're worried about attitudes to maths, we actually possibly contribute to making them worse than they might be. And what you're
Yeah.
saying is actually very positive, but maybe they're good.
Yeah,
Yeah.
I know. I think you're right. I think that's a risk. And I've not quite worked through in my head all of the repercussions of that. But no, I
No.
think you're spot on.
Yeah. No, that's definitely food for thought. Yeah. And David, I mean, I think what we can do is perhaps we can put a link to the research that you're talking about in the that people can click on to be able to go and have a look and see what they think.
Yeah, absolutely. And all of the stuff that we've got we'll be making available. So share a link, and we're very happy to share data tables and stuff. And if people want to get into having a look at this and understand attitudes more, we're very, very happy for them to dig into the data.
Oh, that's fantastic. Actually, you've got but a whole other conversation could start now. I just wish that for any kind of research that the data was freely available so that people could then you can't accuse people of spinning data because the data is there for you to look at yourself. Wouldn't the world be a better place if that was standard practice?
Yeah, yeah, yeah. I'm with you on that.
Right. Okay. Well, David Thomas, thanks very much for talking to me. I think some really fascinating things there, and things that I say have changed, changing my views about attitudes to maths, and changing increasing my understanding perhaps about this key stage 2-3 transition, and what we need to do as a maths teaching maths education community is to think about what we can do to help prevent that from happening.
Huh? Pleasure to
Great.
chat.
Thanks very much.